I'm Mike Giuliano, a computer scientist in the Manufacturing Engineering Laboratory at the National Institute of Standards and Technology. A Manufacturing Engineering Toolkit, or METK, is under development in NIST's Manufacturing Systems Integration Division, which is part of the Manufacturing Engineering Laboratory. The toolkit is intended to allow manufacturers to bring products to market quicker by having computer-aided manufacturing engineering applications perform engineering functions in the product lifecycle. In order to facilitate rapid research and development of the toolkit, NIST is also developing a virtual manufacturing system. The virtual system will provide the environment in which the manufacturing engineering toolkit will be used. By utilizing the virtual manufacturing system, researchers at NIST can bypass some of the physical limitations a real manufacturing system will present. Researchers can test different manufacturing scenarios in a shorter time span. In some cases, scenarios could be tested in hours, minutes, and sometimes seconds. The initial scenario involves the production of a test part in the virtual system. The test part is machined on a vertical milling machine. The engineering data for the part was specified in the simulation package in which the virtual system is implemented. This facility-level engineering data includes routings, tool crib operations, and fixturing operations. The routing in the system sends the bar stock to the vertical milling machines. Once the part workpiece arrives at the milling workstation, machine-level engineering data is used to machine the part. The machine-level engineering data for this part is generated by the Manufacturing Engineering Toolkit. The Manufacturing Engineering Toolkit will consist of the following computer applications: product data management, computer-aided design, routing planning, operations planning, and production simulation. The data generated by these applications is captured in the product data management application. The current toolkit does not contain a routing planning application, which is intended to be added in the near future. Using the current toolkit, researchers can originate CAD designs, import the design into operations planning applications to generate the machine-level engineering data, and simulate the machining of the part on the vertical mill in the virtual system using the generated data. The toolkit will also capture all source files in the product data management application. The product data management system also provides a business workflow capability that allows modeling of manufacturing personnel interactions within a facility. A business model for the production of this part is implemented in the product data management system. This business model is centered around an engineering data package object that represents the machine-level engineering data required to produce the part in the virtual system. The data package consists of an NC program, tool list, fixture list, geometry model, operation sheet, and route sheet. The product data management system has a schema that can be instantiated to implement a business model. This is a depiction of the NC program object's instantiation in the business model of the test part. The NC program object passes through several states: a generation state, a translation state, a validation state, and an approval state. In the generation state, the operations planning application is launched to generate the NC program. The resulting source file is checked into the product data management system. The person in the workflow who performs this is the process planner. When the process planner is done, automatic notification is sent to the NC programmer that the source file is ready to be translated. This is the desktop of the Unix workstation on which the Manufacturing Engineering Toolkit is implemented. In the lower window is the Product Data Management System. In the upper window is the computer magnification of the Product Data Management System. This is used due to a small font size. The business model implemented in the Product Data Management System for the part is shown. It consists of the tool list, fixture list, NC program, route sheet, geometry model, and the operations sheet. The first engineering task is design. A prior similar design file is checked into the Product Data Management System. The Product Data Management System controls access to the file. The designer can edit the file and make modifications to the design to create the new part. When the designer is finished, the updated file can be checked into the Product Data Management Geometry Model object. The designer interacts with the Product Data Management System to change the status of the Geometry Model object from a generation state to the approved state. This status change automatically notifies the process planner to begin operations planning. The process planner interacts with the Product Data Management System, launching the operations planning application to generate the NC program. The process planner interacts to perform several steps in the operations planning for the part. The first step is to perform automated feature recognition. In this step, the solid model geometry is scanned to detect machinable features. The next step is to specify whether the part is to be machined on a 3, 4, or 5-axis machine. Once the features and the machine type are known, the number of distinct setups for machine configurations can then be determined. The specific machine of the correct machine type is then specified. The tools and fixtures of the specific machine are then specified. Once this data is entered, the operations required to machine the detected features using the tools and fixtures of the specified machine can then be determined. When the operations are known, the toolpaths are generated and the apt file format of the NC program is produced. Now the operations planning data is generated and ready to be validated in the production simulation application. This is the simulation model that is generated to validate the operations planning data. All of the operations data that was generated is present in the simulation model. The tooling, fixturing, NC program, and part bar stock. The NC program actually executes in the simulation environment. Taking a closer look in the simulation, one can see that as the NC program executes, the tool is being geometrically removed from the workpiece in the simulation. The simulation environment provides the ability to capture problems in the NC program. In this case, collision detection has been set up to detect collisions between the tool adapter and the workpiece. In this simulation, a crash actually occurred because the adapter was too wide to fit in a pocket where a hole was to be drilled. The simulation is stopped at the collision to allow further inspection to identify the problems. Since a problem has been found, the engineering data can be regenerated to correct the problem. By identifying the problem in the simulation and not on a real machine, expensive downtime and possible machine damage has been avoided. The simulation in the virtual manufacturing system models the routings, tool crib, and fixturing operations required to produce the part. The raw bar stock comes into receiving, is put on the raw storage racks, then it's taken down and cut off by the bandsaw into small blank workpieces. The boxed workpieces are forklifted to the vertical milling machines. In parallel to this, the tool person has gone to the tool crib to retrieve the tooling, and the fixturing person has retrieved the fixture for the vertical mill. So if the simulation is halted at a moment in time, it is determined that all the necessary logistics to machine the part at the machine have been satisfied. The proper tools, fixtures, and workpiece stock are on the vertical mill, ready to be machined. The virtual manufacturing system will allow researchers the ability to test different manufacturing scenarios in a research environment using the latest in computer-aided manufacturing engineering applications. The Manufacturing Engineering Toolkit will be used to generate the engineering data to be validated in these scenarios. Researchers at NIST believe that this virtual system and computer toolkit technology could lead to next century solutions to manufacturing problems.